the Daily Space for today, September 12th, 2019. Welcome to the Daily Space. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Most Mondays through Fridays, either I or my co-host Annie Wilson will be here to bring you all that is new in space and astronomy. And today's news didn't start anywhere that any of us really anticipated. This morning I got up and this was the meme that I found facing me on social media. This morning, looking at this, I knew something pretty awesome had happened. And that's because this meme implies something even cooler than Oumuamua has come along. For those of you who don't remember, Oumuamua is an object that was discovered back in October of 2017 by Pan-STARRS. It was discovered after it had been past the Earth, after it had been on its closest approach to the Sun, and as it was on its way out of our solar system. Now, not only was it on its way out of our solar system, but it had actually originated outside of our solar system. Everyone got excited. Papers were written explaining how this cigar-shaped object was either just a really weird rock in space or was maybe even an alien spaceship or a light sail. Once again, I want to say it is not aliens. It is never aliens. Until, of course, it's aliens, but that requires far more evidence than Oumuamua gave us. So, with this new object, it turns out it's not on its way out of the solar system. It's on its way in. And this is what's particularly exciting. With Oumuamua, since we didn't find it until it was moving away, we didn't have time or ability to get all of our best telescopes pointed at it when we could have gotten the best view. But with this new object, well, there's some really cool new potential. 2019 QR Borisov is a newly discovered comet that was found by Ukrainian amateur astronomer Gennady Borisov back on August 30th. So this is a really recent discovery. In the weeks since he found it in his images, astronomers everywhere have been pointing pretty much every telescope they can get their hands on at this new object, trying to figure out what exactly is its orbit? What is it? Where is it going? And most importantly, where did it come from? Well, yesterday, a new astronomical telegram came out, and it is based on 129 astrometric positions. This is where the position of the object has been very carefully measured against background stars. And from those 129 measurements that are spread out over 12.4 days, well, we now know this is an object that is on what's called a hyperbolic orbit, an escape path. And it has an excess speed of 30 kilometers per second. It has an excess speed of 30 kilometers per second, which is a fancy way of saying it's diving through our solar system and it's not sticking around to stay. This object will make its closest approach to both the Sun and the Earth in December, when it will be roughly 1.96 astronomical units, so about twice as far as the Earth away from the Sun, and 1.89 AU away from the Earth. It's going to be closest to Mars during this point. And it's actually going to be a little further out from the Sun than Mars is. So it's not getting too close, but it's getting close enough. And for the next few months, I anticipate an observing frenzy as everyone with a large enough scope catches their own glance at this object from another star. How often do you get to say that? A comet that came to us from another star. I can't predict what we're going to learn scientifically about this object, but when the papers are published, we will be here to bring them to you. And remember, this was found by an amateur astronomer. It's only getting closer. It's only getting brighter. So get ready to, if you have your own scope, take your own observations. Now, from a comet from another solar system that is invading our system, we move out to another news story that is exploding across social media. And this is a story based on a new paper in Nature Astronomy that describes a world that the Hubble Space Telescope was able to observe water vapor in its atmosphere. Now, this has led to a lot of people, a lot of, well, not very scientifically trained journalists, all making the claim that, well, maybe this is Earth too. Maybe this is that object that, well, finally starts to look like our own world. And the reason that they're going to these great lengths in discussing it is because not only does this object have water vapor in its atmosphere, but it is also located in its solar system's habitable zone. This is that region in a solar system where sunlight alone is enough to allow water to exist at its triple point as a water, a solid, or a gas within a planet's, well, environment. Now, there are other ways to get a habitable world through tidal forces and things like that, but we can't see those kinds of factors from here. So when we're looking for potentially habitable worlds, we're generally looking in these habitable zones. Now, the thing is, this extrasolar planet, which is ever so awkwardly named K2-18b, this awkwardly named planet may have water in its atmosphere, but that does not mean it's an Earth 2. And a lot of astronomers have been jumping on social media to basically crush everyone's enthusiasm and break their dreams that this might be a world capable of supporting life as we know it here on Earth. As much as people would like to proclaim that this is Earth 2, and I don't want to crush your dreams, but I'm going to crush your dreams. This is not Earth 2. This particular world is actually 8 Earth masses in size. And that puts it, well, halfway between Earth and, well, Uranus in mass. This is either a super Earth or a small ice giant, sub-ice giant, sub-Uranus world. And while its atmosphere does have water vapor, it also reflects those things that we'd expect more in a Uranus or a Neptune. Its atmosphere is actually rich in hydrogen and helium, things we don't really find hanging out in our atmosphere. So, yeah, its atmosphere and its mass aren't very Earth-like. And then on top of that, it's not orbiting a star anything like our own sun. Rather, K2-18b is orbiting a cool dwarf star, which means it's on an orbit so close to its star, because its star is smaller and cooler and fainter, it's probably experiencing tidal forces from its star, like we're more used to experiencing from our moon. So yeah, it's not an Earth 2, no. But this world is still awesome. And here's the thing. Science advances incrementally. We learn things one step at a time. We develop tools and instruments, one small innovation at a time. And with this world, we now know that we can detect water vapor in alien atmospheres. We can detect water vapor, and that means we can potentially find Earth 2. This isn't it, but this is how you get there. Now, there's still innovation needed. We need to get better at finding smaller worlds. We need to get better at detecting faint atoms, low abundance atoms in planetary atmospheres. But we're getting there. And this is a step along the way. And this is also a step that helps us figure out just how often is there water vapor in the atmospheres of other planets. It's a small step, but it's a step we have to take. Okay, so that's my hot take on this not Earth 2 water vaporous world with an awkward name orbiting a little tiny star. And from there, I'm going to bounce to what is an astronomical image I'd actually love to hang on my wall because it looks like abstract art. This next story takes us to the region around our galaxy's supermassive black hole. And this particular image comes to us from Meerkat, a new radio array that is functioning down in South Africa and is, well, helping to blaze the trail that will be followed on by the Square Kilometer Array in future years. This new image is the most sensitive image we've taken so far in radio wavelengths of the area around Sag A star, the supermassive black hole in the center of our galaxy. And what we're able to see that we haven't been able to see before are these faint bubbles around the bright filaments of radio emission. And these bubbles that you see in this image, those bubbles are places where high energy events that have taken place in the past millions of years have slowly pushed out the dust and gas of the interstellar medium. Now, according to William Cotton, one of the researchers in this study, this eruption was possibly triggered by vast amounts of interstellar gas falling in on the black hole, or a massive burst of star formation, which sent shock waves careening through the galactic center. In effect, this inflated bubbles in the hot ionized gas near the galactic center, energizing it and generating radio waves that we eventually detected here on Earth. This new image, with its high resolutions, with its ability to detect super faint structures, is revealing a new stage in something that we already knew had been happening. As we look towards the center of our galaxy in a variety of different wavelengths and a variety of different scales, we see structures of bubbles that are growing in size over time, that are shocking the interstellar medium, and that can be traced out in radio and X-ray emission. These new images just give us one more picture on what appears to be a long history of our Milky Way, well, blowing bubbles and sending those bubbles out to shock the material in the inner part of our galaxy. Now, this particular story isn't all that remarkable. It isn't all that shocking. It is beautiful. And it's an incremental update on what we already knew. Our galaxy is constantly experiencing this low-level activity. But what I find most interesting is the timing of this particular science. Because at the same time that we're getting this story showing us these amazing filigree bubbles, we're also getting another story coming to us from Andrea Gett's team at UCLA, where they've been using the Keck Observatory to peer into the very center of our Milky Way galaxy. And as they do, they've periodically been seeing these flickers and flashes of new things coming literally to light. Now, Andrea and her team have been looking at the center of our galaxy for going on 2 decades. And it's only been in the past few months worth of observations that they've been seeing these kinds of outbursts of light occurring. And this is showing that for some reason right now, our galaxy is going through one of its little tiny active periods. I wouldn't call our galaxy an active galaxy, but for reasons that they don't know, right now there is stuff falling in on that supermassive black hole, and in its last moment of being destroyed before it falls in and has its light consumed forever, we're catching the light that's being given off during these destructive processes. And they don't know why right now, of all times in the history of looking at this object, the Milky Way is eating stuff. And I just want to assure any of you who are reading the press releases and the journal articles and who are like, oh, our black hole suddenly started eating things. Our black hole isn't reaching out and grabbing food to shove into its mouth. Our supermassive central black hole is sitting there passively while our galaxy, for whatever reason, flings food in at its surface, by which I mean stars and gas and planets and stuff like that. And now there's going to be astronomers out there trying to figure out, where is this inflow of material coming from? And the answer is probably that there is an interaction between a few different objects. Something got knocked into a new orbital trajectory, and that particular orbit through our galaxy just happened to intersect with the surface of the supermassive black hole's event horizon. And that sounds dire and drastic, but, well, the science that happens at one scale happens pretty much at all scales. And in our own solar system, we periodically see our sun eating comets. And it's not like our sun is going, hey, Oort cloud, send me some food. It's interactions going on out in the distant parts of our galaxy that are causing new objects to get shuffled inwards, some of which that happen to have unfortunate orbits that cause them to get eaten. So the science that happens here happens out there. Sometimes it's our sun that's eating things, and sometimes it's the supermassive black hole in the center of our galaxy. And that's all I've got for today. That rounds out our science. And I would like to remind all of you that I will hang around and answer your questions, but you need to @ me in the chat. Please @ CosmoQuestX. And we are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. Each episode is produced by Susie Murph, and on Wednesdays, Annie is here doing our weekly rocket updates, and on other days when I'm escaping to do other things, Annie will be here as well. And every Sunday, you can find her doing the Sunday Science Hour. Both our Sunday show and our Monday through Friday news shows all come out at 1 p.m. Eastern. That is 10 a.m. Pacific, 6 p.m. London time. And that's not all we do. We also bring you live events, from rocket launches to landings to viewing parties for other streams. We're here to just fill your head with science. So give us a follow. Follows are free, and it will get you notified whenever we go live with science content. Now, this is September, and my understanding is all subs are running at a discount. We have a sub goal this month, and we would love your help to reach 50 subscriptions and resubs for the month. This is how we're able to pay Susie and Annie a living wage. This show is here thanks to the generous contributions of people like you. And every bit, every sub, and every bit of patronage over on patreon.com/CosmoQuestX, well, it all helps to make this show possible. Now, if you can't help us financially, we totally get it. Please just spread the word. Help others know that we're here, because you never know who may need a little bit of science in their life. Okay, that's all I've got. I am now going to take a look and see what questions you may have. And my chat has like no chat in it. Okay, I'm going to switch devices. Ed Thompson, thank you for the bits. I don't know why my phone is not giving me the chat. Okay, I have chat history on my phone, just not on my iPad. Okay, scrolling back. I see Hexacoron has the emotes for Paranor stream. I so totally need to get me a never enough coffee emote. Hello, Susie Murph, and your doggy assistant, Jake. Hello, Mythtown. Hello, Paranor. Hello, DPI209. I'm sorry. So I can't actually read the chat unless I switch apps when I'm sitting over here. I need to figure this out better. It's on my list of things to do Saturday. I'm just going to redo the studio again to try and figure out how to make this work better. I'm sorry, Malerna. I'm so sorry. I'm sorry, the Raven Lillian. I'm I'm sorry, Larry Weird and Mike Cassidy. Ah, so much technology flail. So much technology flail. Um, Hello, Ruffs Matt. Hello, Daddy Cupcake. Hello, Roria Rose. Thank you, Mythtown, for the bits. Hello, Planetary Pan. Thank you, Wayne Johnson, for the Subway bits with the bonus bits. I hate the icon. I totally hate the icon, but I totally love the bits. Hello, Sidemit. Scrolling. I'm sorry that I'm forcing you to cover your dog's ears, Mythtown. Eddie is a strong contender for cutest dog. He really, really is. Am I still streaming? I just got a message on my phone that the channel went offline. I can't see. Can someone tell me if I'm streaming? I'm so confused. Okay, I'm still streaming. I'm not sure what's going on. Yes, Daddy Cupcakes. Eddie is completely tailless. He was born that way. Australian Shepherds have 3 different genetic variations on their tails. There are tailless dogs. There are bobtailed dogs that have these little tiny tails, which is what both Stella and Malachi have. And then there are regularly tailed dogs. I don't have one of those. They're dangerous to coffee tables. I like what Bad Panda wrote. All dogs are the cutest dog ever. Yes, that works. I have no clue what's been up with my technology and the determination to mute everything. Thank you, Trekker Kev, for trying to get my attention with bits. Hello, fellow hoodlum. Scrolling, looking for questions amidst all the mutedness. Thank you, Sidemount, for the sub with Twitch Prime. Thank you so much. Eddie's like, do I get something? Do I get something? Yes, you can have something. Come here. The look I got. Come on up. You're so good. So good. He is my good dog. Technology is ornery. It is. Okay, so I'm not seeing any questions, but it seems like my technology is at least working. Now, I don't know if there were questions that my phone simply decided I wasn't allowed to see. So if you had a question and I didn't answer it, please type it back in. All right. So the question of the new potential Earth-like planet, do we know its radius? I didn't see its radius listed in any of the things I looked at. That doesn't mean there isn't a paper out there that has its radius. We are sometimes able to get the radius of extrasolar planets by looking at how long it takes for them to go from not blocking their star to fully blocking their star. And that gives us a sense of how long it takes the fullness of their size to pass in front of the star. At some point, I need to explain all of that math in detail. But no, I didn't see anything explaining that. Yeah, 8 times the mass. So if it has 8 times the mass and half the density, that would require me to do math to figure out its radius. That would make it significantly larger and would make it more of an ice giant than a super Earth. Okay, so Planetary Pan found it somewhere other than where I was looking. So she found it. It's 3 times the radius. So definitely we're looking at super Earth territory. One random fact that remains one of my favorite random facts. Were you to stand on what is generally considered the surface level of Saturn, which is still gas, so you can't stand there, you would weigh pretty much exactly what you weigh here on Earth because of the way mass and radius work together to figure out what gravitational acceleration you're experiencing, and your weight is just an expression of the gravitational acceleration that you're feeling at any given moment. So yeah, and Saturn would totally float in a bathtub if you had a big enough bathtub. Hexacosacoron is like, it's the wrong pale blue dot. I actually posted, not knowing this story was coming out, one of my paintings last night, and I named it the wrong pale blue dot. So that will be coming out later today on my personal social media feed. So Planetary Pan is saying the upper limit for rocky planets is about 1.23 times the size of Earth. So definitely mini Neptune. Thank you, Planetary Pan. This is where I need to remind everyone I'm an astronomer, which means I've taken 0 classes on planetary science, and everything I know I've had to learn on my own. So I do my best, but I'm really grateful that we have people like Planetary Pan around to help. Okay. I'm not seeing any more questions coming in. So I think I'm going to call it a day. Currently, my plan for the rest of the day is to go record this episode as a podcast. I still need to work on revising the script. And I'm going to remind all of you that if you want a clean run, no technological difficulties, everything worked, the audio is edited version of the show, you can get it. It is now available on iTunes. It is slowly coming to all the other podcast directories near you. We will link to it in the chat and everywhere else that we can. If you can please go subscribe to it. You don't even have to listen to it. If you can go subscribe to it, it will bump it up in the search algorithms. One of the things that we're finding is when you name your show The Daily Space, there are so many other shows out there that include the word space and daily that no one can find you with the search engine. So if you can give us some search engine foo and help us rise to the surface of the search engine, I would greatly appreciate it. So that's all I've got. As always, if I get enough done, I will be doing software development. And if I'm doing software development, I just might be doing it here on Twitch. So yet one more reason to give us a follow. So as always, this has been The Daily Space. My name is Dr. Pamela Gay, and I have been here to put science in your brain and to cause all manner of technological difficulties, because that's what I do. I don't mean to cause technological difficulties. This is simply my reality. I create technological difficulties and apparently inadvertently switch pages instead of running credits. Okay, that should be the credits running. My name is Dr. Pamela Gay. I am here to cause technological difficulties and put science in your brain. We bring you The Daily Space most Mondays through Fridays at 1 p.m. Eastern. That is 10 a.m. Pacific, 6 p.m. London time. This show is hosted by both myself and Annie Wilson. And Annie's also here on Sundays, bringing you the Sunday Science Hour at the same time, same place. When we're not here bringing you the news of the Sunday Science Hour, we might just randomly run an episode where we're co-streaming another show, where we're writing software, and where we're covering launches, landings, and other special events as they happen. We are here because of you. We are here thanks to the generous contributions of people like you. And what you give is tax deductible where the law allows. This is a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. Our episodes are produced by the ever amazing Susie Murph. And because I know she's waiting for my audio and everything else, I'm going to go get to work on that. So, wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you on the other side. Bye-bye. Awkwardness. There we go.